the intelligence of the new generation of robot dogs. It doesn't breathe, it doesn't blink, it doesn't get tiring, but it can run, climb stairs, open doors, recognize your face, and even make decisions by itself. The robot dogs of a new generation are not only mechanical, they're intelligent. Robot dogs are not only replacing military dromedary patrol forces, but are also replacing warehouse employees, disaster recovery tasks, and research laboratories, creating AI, becoming one of the most sophisticated autonomous machines ever created. And what really makes them radical is not their legs, it's their brain. Adaptation to autonomous intelligence, remote control toys. Robot dogs used to be regarded as simply another type of remote control. They were able to walk, perhaps turn, perhaps make an electronic bark, and yet they were not aware, no choice making, no flexibility at all. They were not machines that were smart. They were but machines carrying out orders like a toy. However, the models such as Spot and Unitree Go 2 are an entirely new species of technology today. They are not ordinary robots any longer. They have 360-degree cameras, LiDAR sensors, depth perception systems, inertial measurement units, and powerful artificial intelligence processors that enable them to know what is going on in their surroundings. And there the true revolution is. Rather than adhering to instructions one step at a time, the contemporary robot dogs learn the world around them in real time. They do not simply carry out orders. They respond. When something is changing before them, they do not freeze. They adjust. They adapt. They continue. Intelligence is the major transformation. These are a combination of high-level AI, real-time sensors, edge computing, reinforcement learning, and autonomous navigation. It is no longer simply a matter of more or less imitating a dog movement, but now it is the matter of imitating the possibility of a dog to react, to recover, and make a decision right away. And here's the scary part. When robot dogs have advanced this fast, becoming autonomous machines, what will become of them when they advance a step further? Since what you are looking at is just the tip of the iceberg of what they can do tomorrow. The way robot dogs perceive the world. Robot dogs do not make a human perception of the world. They do not count on feelings, intuition, or intuitive sight. Rather, they create a virtual map of reality, so to speak. They are almost always creating their own virtual universe as they go. Their primary weapon is LiDAR, which is light detection and ranging. The principle of operation is that it emits laser pulses that reflect off surfaces and bring back information on distance, shape, and structure in detail. After this, they then merge the data with computer vision and depth sensors and generate a 3D model of their environment that is constantly updated. Then, in case a stair comes, they work out step height. When they are blocked by debris on a path, they reroute. When one walks in their direction, they follow movement. They aren't guessing, they're measuring. This wholesome procedure is referred to as simultaneous localization and mapping SLAM. And the best thing about robot dogs is their SLAM, which allows these dogs to find their way in entirely new environments without human assistance. Think about that. They do not require an inbuilt map. They don't need a guide. They move into an uncharted territory and begin perceiving it immediately, as a living being does the exploration of the new area. This is why these machines can be used in disaster areas, warehouses, industry, and unreliable surfaces. They are not simply intelligent in walking, but in being aware. They are spatially conscious, so to speak. But vision alone isn't enough. Seeing the world is one thing, surviving in it is another. And the actual test happens when their balance is tested, since it is the movement where robot dogs shine. Movement, intelligence, and balance. It is a movement in which robot dogs cease to appear like machines and begin to appear nearly alive. See a current quadruped robot get back on its feet. It trips, counts, rearranges, weight balances, and gets on feet, all within milliseconds. And the most outrageous fact is this. It is not pre-programmed choreography. It is real-time control that is AI-powered. These robot dogs are continuously computing center of gravity, joint torque, surface friction, and momentum. Each choice is a mathematical one. All movements are calculations that occur beyond the ability of most human beings to even respond to. And when the surface is different, as it is with slippery ground, or smooth and rocky, with loose material, they do not panic. They adapt instantly. Their balance is adjusted and their body is thinking because their legs rearrange, their weight is redistributed, and their balance is restored automatically too. There are even models that rely on reinforcement learning, i.e., they were trained in a simulated environment several thousands of times before being allowed to enter the real world. They learn how to fall, how to recover, how to optimize their gait. That's not just robotics, that's learned intelligence. This is how robot dogs are able to climb stairs, run through rough surfaces, and stand on their feet in the environment that would fall instantly when a regular robot would be used. Millions of years were spent by nature perfecting animal motion. It is now being copied using algorithms and sensors by robotics engineers. But here's the question. In case a robot dog can be taught to walk, recover, and become better in its motions, then what more can it be taught? It is not simply physical intelligence, and this is why the next step is not physical. The second one is behavioral intelligence, autonomy, and decision-making. Here is where robot dogs cease to be impressive and begin to be disturbing. Robot dogs in the new generation are not only physically intelligent, they are becoming behaviorally intelligent. They are able to patrol on their own, detect abnormalities, acknowledge particular individuals, act on voice orders, and work automatically. That's not automation, that's autonomy. Robot dogs are used in industrial environments to check pipeline leaks and so on. They also patrol sites and notify operators of suspicious activity in security-related jobs. They go through this in the areas of disasters as they maneuver the rough terrain to find survivors. And the most powerful thing about this is that they are not reading off the papers. They follow objectives. When one path is impassable, they take up another. When the battery is depleted, they go back to a charging station. When sensors detect something out of the ordinary, they signal it. This is prioritization, one of the most valuable indications of intelligence. A machine is controlled remotely and awaits the instruction. Yet, an independent robot dog proactively analyzes the surroundings and bases its actions according to its mission. That is why they are activated in the practical situations rather than in the laboratories. And here is the reason why the world is listening. Since a machine will be able to patrol, detect anomalies, and make decisions without human supervision, it will go beyond a tool. It is turned into a mobile decision system. How does it process vast amounts of data in real time without depending on an internet connection? Such a response is the reason robot dogs are even more dangerous and revolutionary. It's AI at the edge. AI at the edge. The majority considers AI as relating to the cloud, big servers, the internet signal, and distant processing capability. Robot dogs cannot sit around until they are connected. They can't hesitate. Even in real-world missions, even the slightest delay of a second may translate into failure. This is the reason why so many robot dogs treat information locally. This is referred to as edge computing. It implies that the decisions are made instantly, no lag. Waiting starts nowhere at all. The presentation of object recognition, navigation, obstacle avoidance, and motion planning is handled by AI chips installed within the robot, and it is performed directly within the machine. So even without the internet, even without the robot in the middle of a rubble pile, even without any communication, the robot dog still operates. This is why robot dogs are so effective in search and rescue operations after an earthquake. Human responders may struggle to enter unstable structures, but a robot dog doesn't hesitate. It doesn't fear death, doesn't worry about danger. It simply moves forward, scanning and mapping everything around it. And because its AI is running inside its own body, it becomes independent of external systems. That independence is power. It's the difference between a machine that needs constant control and a machine that can think and act in real time. It's also why robot dogs are being deployed for military research, industrial inspections, and security patrols worldwide. But now imagine something even bigger. Imagine not one robot dog, but 10. Imagine them communicating, sharing information, dividing tasks, and coordinating movement like a real pack. That's the next leap. Swarm intelligence. Swarm intelligence and communication. Making it possible so that a single robot dog can become smarter is not the next step forward. It is the multiple robot dogs hooking together. Swarm robotics comes in at this point. Robot dogs are also able to communicate, share maps, divide tasks, and coordinate movement like actual pack animals. And when you add personal intelligence to communal strategy, you do not simply have a robot. You get a system. Suppose it is a disaster relief mission. One of the robot dogs comes in at the east part of a collapsed structure. Another scans the west. A third underground check tunnel. They combine the information instantly, creating a complete map faster than any single machine could build on its own. That group intelligence entails quicker search coverage, inspections that are coordinated, and redundant safety systems. The failure of one robot does not stop the rest. In case any member discovers a roadblock, it notifies the whole group. In case the danger is detected, the pack changes. Individually intelligent, collectively powerful. That is what swarm intelligence is so terrifyingly effective. A swarm does not simply do something. It is an adaptable unit. It acts as a living organism in which all the machines get attached to a bigger brain. It is no longer science fiction. It is already being experimented and developed at AI research laboratories, industry, and wartime science laboratories. Their utility is compounded as soon as the moment robot dogs begin to act like an organized pack. They are quicker, more intelligent, and efficient than human beings in some activities. But here's the twist. The swarm intelligence is not created to serve experiment purpose. This is under development since the world has real-life applications of these machines, and those applications are increasing at a high rate. Real-world applications. Robot dogs are not just experiments anymore. They are deployed, and the intelligence behind them is already being used in industries that affect everyday life. Let's look at where these machines are proving their value right now. Industrial inspections are one of the biggest uses. Robot dogs patrol factories and power plants, detecting heat signatures and equipment failures. They can move through dangerous areas where humans would need protective gear, and they can inspect machinery for problems before disasters happen. Law enforcement and security is another major area. Robot dogs monitor large facilities, reducing risk to human officers. They can patrol autonomously, identify anomalies, and alert operators to unusual activity. Instead of placing humans in harm's way, these machines become the first line of observation. Military research is also a major driver. Autonomous mobility in unpredictable terrain is a huge advantage. A robot dog can carry equipment, scout terrain, and operate in environments where traditional vehicles fail. Then comes disaster relief. Robot dogs can enter dangerous environments too risky for humans. Collapsed buildings, unstable debris, hazardous zones. These machines can go in first, locate survivors, and map the area. And finally, research and education. Robot dogs are now used in AI and robotics programs worldwide, helping scientists and engineers push machine intelligence even further. Every one of these applications proves one thing: robot dogs are becoming part of real operations. But something even more surprising is happening. Robot dogs aren't just being designed to work. They're being designed to interact, to respond, to simulate companionship. And once machines begin imitating emotional behavior, the line between tool and companion starts disappearing. Artificial intelligence and emotions. Here's something unexpected. There are robot dogs which are undergoing development to react to human emotion. And that's the moment this technology stops feeling like pure engineering and starts feeling almost human. Robot dogs can adapt to the approach taken by a human using voice tone analysis and facial recognition, which means that they can change their behavior. When a person walks in a calm manner, then she stands still. When one is aggressive, he or she changes position. They are able to act like they are interacting with someone to a point where people start responding emotionally to it just as they would to an actual animal. At this point, we need to be explicit. These machines are not conscious. They are not emotional. They do not love, fear, or are loyal. However, it is the manner in which they react that gives us the impression of emotion. And that illusion is strong. Human beings are geared towards associating themselves with living things which respond to them. That is why for thousands of years, dogs have been companions. Engineers are currently attempting to reproduce that bond artificially. And this confounds the distinction between machine and companion. A robot dog which can identify your face, tell your voice, and behave differently according to your voice tone is more than a tool. It turns into something you may believe, something you might rely on. But here's the real question. When human beings also start to have an emotional connection with intelligent, autonomous machines, what occurs as soon as they're applied to surveillance, security, or military application? Since the emotional interaction makes robot dogs friendly, but they are powerful because of their intelligence. And power always asks larger questions, questions which go above technology and into the realm of ethics, society, and power. And after you begin to think of those questions, the future of robot dog intelligence is not only exciting, it's complicated. The level of intelligence of the new generation of robot dogs is something that goes beyond robotics. It is a transformation of the interaction of machines with the world. They are no longer factory floor appendages. They move, they adapt, they decide. LiDAR vision and SLAM navigation, reinforcement learning movement systems, edge computing and swarm intelligence. These machines are changing at a pace that is much faster than most individuals would guess. And as their intelligence grows, they are likely to be present in our life more of the time. The software is even more impressive than the hardware. Smarter algorithms, better neural networks, faster processors. It is not just that we are creating robotic pets. We are developing AI systems on mobile. And now it is not only whether robot dogs will become more advanced or not. They will. The true question is, how are we going to make use of them? So now I want to hear from you. Do you have confidence in a robot dog to guard your neighborhood, to assist in emergencies, to work alongside humans? Or do you believe that autonomous machines are progressing too fast? Comment below. Like, subscribe to further cutting-edge tech content, and enable notifications. The future of robotics does not lie on the legs of 2 feet, it's running on 4.